Hi, I'm Ashwan Sai, and today I'm going to explain you about my AI project. My AI project is about the frozen lake, and I have implemented it using various algorithms like DFS, reinforcement learning, and dictionary algorithm. The first step is to import the libraries, and then next we need to make the environment. I'm making an 18 to 8 environment with random mode human, which means you'll get a window like this. Just give me a minute, I'll just slide it over so that you can see it clearly. Now for the action space, the agent can move up, down, left and right. And the observation space, the agent can be in any of the spaces here. Now let us take an action so that agent moves. We can't see it clearly, but when I test it with 15 moves, we can see this clearly. See the agent is moving so that we can work on the training now. For the training, I have initialized the queue table with zeros, and then I'm making another environment here, and all the parameters are set here. Alpha is the learning rate, gamma is the discount factor, and epsilon is exploration exploitation trade-off, and I'm training it with 20,000 episodes. This is the algorithm, and the random action is based on the epsilon. We need to choose an action, and we'll update the Q table using the formula. This is the Bellman's formula, and let us run it. It will take time. It's around 20,000 episodes, so it will be over now quickly. Yeah, it's done. And let us check if the Q table is populated or not. Yeah, it is populated. So let me close the environment and create a new one with random mode is equals to true. Just give me a minute, I'll slide it over here. Yeah. Now for testing, by using the Q table, we can move. See, the agent reaches the goal because we are using the Q table here. With the help of Q table and choosing the best possible action, it is moving to the target. Let me close it. And if we plot the rewards here, you can see initially it takes time to reach 0, and initially it increases, and then after 13,000 episodes the reward is always 1 because the agent has learned. So now for DFS environment, let us create another environment, and this is the random map. Just let me slide it over here. Yeah, it's done. And for working in DFS, it is a graph algorithm, so we need a graph or a matrix. So I'm converting it into matrix using some Python basic code. And then this is the DFS algorithm. I'm using stack. I'm traversing through all the directions, and this is the algorithm. I just run it. The path is found, but the path is in the form of coordinates. We need to map it to the actions like this. If we map it, these are the actions that the agent should take to reach the goal. Now, let me delete this. Now for testing, I'll just, if you see carefully, the agent is not taking the shortest path, it is taking time to move. So let us try some more examples to see it clearly. Sorry. Yeah. So now for dictionary algorithm, I'm using the heap, and then the priority queue, the movements. Let me run it. So I'll create another environment again, and I'll just slide it over here. And in the same way, I will convert this into a matrix, and then I'll map it. I'll get the actions. Let's see if it works. Yeah, it works, and it takes the best possible moves. It is the minimum path length. Let us try. Now I'm generating a bigger map, and the output is clear. Let us see. I have increased the map size to 8 into 8. Sorry, it's 12 into 12. And then I have performed the analysis. The path length is 34, and the Dijkstra has taken only 22 steps, and the time is a bit higher than DFS. But if I increase the size again to 25, you can see the steps taken for DFS is 144 and the Dijkstra is 48, which is very different. Now the time the DFS took less time and the Dijkstra took higher time. Now I'm increasing the size of map to 50. In the same way, the steps increase exponentially. Here it just took 98, but the time for the time the DFS is more efficient here. In this case, it is a simple environment, so the Dijkstra is getting more time compared to DFS, but when the environment is very complex, the DFS takes much more time than Dijkstra. Overall, the Dijkstra is much more efficient. Thank you.